I want to talk about one other major correctness thing that can sneak up on you without you ever noticing and lead to code that is just wildly incorrect and you would never even know that it happened. And unfortunately, Pandas doesn't give you a lot of ways to really easily become aware of that. Let me set up the scenario for you. One of the things I like to talk about is really simple tools, maybe even tools that have been around for 20 or 30 years that are just outrageously productive at giving you the ability to put together brand new tools or to put together analyses or to put together some kind of automation. And I know in past we've talked a lot about things like shell scripting. We've talked about things like SQL. And one of the things that just makes these tools so powerful is you can start with small building blocks and then build up to create enormously sophisticated results without a lot of work. I want to talk about one more of these tools, and a tool that I feel people kind of get wrong and people don't use enough of in the places where they really should. I want to talk about spreadsheets. So here is our premise. I have some data, and the data that I have is actually originally stored in a spreadsheet. And the reason for that is, if we think back to some of the things that we've heard Cameron talk about, for example, when it comes to visualizations, he likes to talk about the density of number of values you can put on the screen or number of values you can put on paper per drop of ink that you use. Well, if we analogize that to the number of numerical values that we can fit onto the screen in terms of the pixels, the density of how much we can enter and actually reasonably work with in a spreadsheet is amazing. I've got a lot of data on the screen right now, and I'm only using a portion of my screen, but it's still something that any user will feel comfortable scrolling around this thing, entering data, and manipulating it. So here we have some data that probably represents, say, the sales that a fast food restaurant anticipates that they'll have over some period of time. And unfortunately, the gut feeling of the person who is running this analysis is that people are going to start getting tired of hamburgers somewhere into the near future. People will get tired of having French fries, but they'll still order them in some amounts. Milkshakes maybe won't change that much. I guess if it's a hot day, everybody wants a milkshake. And apple pies really aren't that meaningful. And for the rib sandwiches, we only sell at certain times of the year anyway, so maybe we can't really gather that much. Well, they might be wanting to do some analysis of how their business is going to operate as a consequence of these anticipated shifts in the market environment. And one of the things they might want to do is, through some means or another, whether it's gut feeling or a more complex model, kind of predict how many hamburgers am I going to sell in each month? How many French fries am I going to sell? How many milkshakes? And because they want to fiddle with these numbers, they want to kind of go back and forth, they might want to do some hand calculations, they might not have a very sophisticated formalized model for generating these. This might really be just kind of gut feeling for them, which, a senior business leader should have the ability to have a gut feeling for, where the business is going to go. Well, they're going to use a spreadsheet in order to enter this data and to manipulate it and to do little computations off to the side. They'll store information like the sales as well as information about their staffing. So perhaps this is a corporate-owned set of restaurants, and so they have some number of cooks, and they say, when the kids are on vacation, maybe they don't have time anymore. They've gone off, for the summer, and so we don't have as many cooks. Or maybe as a consequence of us seeing reduced demand, we're going to reduce the total number of cooks we have. Maybe we'll keep the cashiers that we have and the supervisors stable. And from information about my cooks, cashiers, and supervisors, and information about my sales, I should be able to do some analysis of how the business is going to go. Well, I really like the spreadsheet for its ability to represent this data in a very compact UI that doesn't require that I spin up a dashboard, that doesn't require that somebody hand edit JSON or YAML. Nobody likes hand editing JSON or YAML. That is something that I can kind of play with and has a very tangible feel to it. I love using a spreadsheet for creating the source of truth for these values. And I'm going to use pandas.read Excel in order to read this in. Now, when I read in this data, I'll do a little bit of additional manipulation on it. I'll make use of, say, an in64 in case there's, with a capital I here, in case there might be missing data. I'll do some Pandas-specific things like rename my axes. For the dates, Excel doesn't really have a lot of choices for how to represent date time values. And so I have no choice but to do a conversion at the pandas layer to turn this into period values, because Excel doesn't really have a notion of periods here. And of course, I'll do a little bit of reshaping. I'll unstack this. So I'll have my staffing information and my sales information. And when we look at this data, we can see, that's the staffing information that we have. That's the sales information. I might also hard code some additional information in the script that I'm going to use to analyze this data set. The reason for that is it is often the case, especially if I'm doing a business analysis, that there are certain factors that I want to play with, that I want to tweak, and certain factors that are not really part of my analysis. And do I really want to have 4 spreadsheets where some of these are really small and just include information like what the hourly rate is for the different roles that I have, or whether they are full-time or part-time roles? Do I really want to have yet another sheet here that I'm not really going to play with or edit with the prices and the costs for each of the things that I'm offering at my restaurant? Maybe not. It might just be convenient enough for me to just hard code these in this script, because I'm not going to play with analyses related to, well, what if we make the hamburger cheaper? I feel like we need to have quality ingredients. We need to keep to that. And I'm not going to play with, what if we make the hamburger more expensive? Because, I want my customers to have a good time, to come to my restaurant, and to not feel like I'm pulling every penny out of their pocket. So what we might have is some combination of data that's stored in Excel and some combination of data that's either in CSV or in JSON or YAML or whatever might be most convenient. And in this particular case, since this is data that I anticipate won't really change that much, I'll just hard code it. Now, there's 1 or 2 small details of this. You might think that if I wanted to represent the full-time or the part-time, I could have a column of this data frame that had a true or a false value. But it turns out that in some cases, pandas is a little bit hard to work with when you have columns that have Boolean values, especially if you want to do repeated lookups, and pandas won't be able to distinguish between, are you, for example, doing a dot lock with a Boolean mask, or you're doing a dot lock with the Boolean values that you want. And so I'll actually store these with some kind of categorical value with the strings here. And so with those pieces included, I can now actually do some very powerful analyses. I can do a lot with this data, just starting with just a tiny piece of code and some nice ways to represent the data input. I could take the per unit multiplied times the sales. Well, actually, that's not going to work. And the reason that's not going to work is if I look at my per unit, my sales, well, they're not going to index align against each other, because you can think that when I take 2 data frames, index aligns on the indices and the columns. And there's really no way for it to figure out how to perform this series indexing against these 2 columns here. It doesn't know that it needs to multiply, say, the price of each hamburger times the number of hamburgers that are sold times the cost. And if you think about it, this is one thing that you'll often see in the data frames that you have. If you can't put a good name on this level of the columns, what this probably means is you likely can't really do index-aligned operations of this entire data frame against something else. Because if there's no way to name this well, there's no singular name that describes what these 2 columns that contain, they're money values, but that's not that interesting of a name to give this, then it suggests that there's really no uniformity. This is really heterogeneous. These are really heterogeneous measurements. And so instead of doing that, what I'll do is maybe I'll join this into one data frame. Well, except one of these is a series, and I can't do a dot join on a series, which is kind of a shame, because you'd think that a dot join operation could just behind the scenes on the series do a 2 frame and then a join, like that for you automatically. But, I never said that the pandas API was particularly consistent or particularly complete. It is actually quite coherent. And so what I'll do instead is I'll actually dismantle these per unit informations into 2 pieces of data. I'll take the per unit, here we'll hide these as well. I'll take the per unit prices and the per unit costs, and I'll multiply those independently. And now you can see if I add those together, I actually get how much money I've made for each one of these units for each unit of time. Or if I'm really thinking pandas-wise, what I'll do is I'll build a new data frame that contains all of this information. And I'll throw away information like what the individual income or COGS, cost of goods sold, are, only at the very end, because there might be some other analyses I want to do on this. So here I have the income that I got from the hamburgers and the cost of goods sold for the hamburger. And if I want to know what the profit generated from this is, well, I can just do a sum across the columns. In fact, I might even combine this with some other information, like I could take some information about, if you're a full-time employee, you work 2,080 hours a year. If you're part-time, we keep you under 34 hours a year, and we only have you on the fry or on the grill 48 weeks out of the year. I could take that. I can do a lock of that against the different roles that I have. I can change that index back to that, so I can see the supervisors are there for 2,080 hours a year. The cashiers and the cooks are only there for 1,600 hours a year. I could take the result of that and multiply that through the hourly rate that I have, rename this, and then, of course, group that by month. So I get something that I can consistently then combine with my other structure and end up with something like this, which is one data frame that gives me my income, my COGS, and my staff pay. And if I do a sum across the columns here, well, I'll get what my actual net would be for that month. Unfortunately, if we look at this, we can see this is not looking good, because if I net this per month, you'll see I feel like there's some rough months ahead for this fast food restaurant. Well, so far everything seems good. And the reason I want to do this is I can now do things which I simply could not do in Excel. As a consequence of Excel having a very fixed notion of how many sheets you have and having a fixed notion of where the data is actually entered, it becomes very difficult to do scenario analysis in Excel. Where scenario analysis is, you take some fixed inputs, and then from that, you oftentimes will do some kind of Cartesian product. You'll do all of these combinations of things that you anticipate happening to then produce multiple outputs, and then you'll do some filtering on those outputs to kind of see what should I do. And so what I really want here is not just an accounting of how much profit I make, because this is all speculative. I'm looking into the future. What I want is a scenario analysis that says, according to our market research, if we reduce staffing by 10%, it will affect sales. People don't like to go to restaurants where there's a long line, so I'll get a 5% decrease in sales. If I reduce staffing by 20%, I'll get a 15% decrease in sales. If I reduce staffing by 50%, I'll only get a 45% decrease in sale. And if I run through these scenarios, can I then take that information and relate that back against my predictions and then see, should we actually reduce the staffing that we have at this restaurant? It's going to have some reputational risk. People are going to say that place is always a mess, but maybe we can eke out some profit in these harder months. And so the whole purpose of using all of these tools, and especially of using pandas, is I can create extraordinarily sophisticated and extraordinarily valuable business analyses in only a couple of lines of code. Here I have the data pulled from Excel. I have the hard-coded data that we have for our roles in our unit. I have my different scenarios that I'm going to run, and here we'll say maybe we'll decrease staffing by 95%, and maybe we can get away with that. So here in this particular scenario of a slight reduction, maybe we lose no sales because, people expect to wait in line if it's around lunchtime. So maybe they won't be that off-put by there being fewer cashiers or fewer supervisors. I'll make use of some pure Python like the name tuple in order to represent these scenarios so I can visually see, there's that scenario and that's what it means. There's that scenario, that's what it means, there's that scenario. I'll make use of some other parts of pure Python like the data class in order to group units of this code together more effectively so I don't have just lots of duplicated code, cut and paste all over the place. So maybe I'll have a data class whose goal is to just calculate some analytical output, for example, the economics as a consequence of this scenario. All this does is take in the sales information, the staff information, the role information, the per unit information, and maybe it'll have a cache property that computes the economics by multiplying all of the things that we did before against the anticipated increase or reduction in sales and staffing. And so we end up with something that looks like the following. And here we can actually, in very little code, less than 100 total lines of code, do something incredibly sophisticated. We can say, under these three scenarios, given this staffing information and given this sales prediction, this is what we'd anticipate to see per quarter in terms of our net income. And we'll just generate one of these economics objects. We'll take the economics information that it has. We'll sum this across the columns to sum the COGS, the income, and the staff costs. And then we'll just regroup this by financial quarter. Now, so far, I've taken you through a path where we started with something very simple and with only a little bit of additional complexity made it more and more and more complex. But the growth in complexity, at least in terms of lines of code, was not as steep as the growth in the capabilities of what this code can do. This code can do some really fancy things in just a couple of lines, and all of this code is orientated around what the decision maker thinks about how the business operates and what they want to see. Because if they said, you know what, we need to add into this some thoughts about, maybe every fast food restaurant is really desperately hiring over this period of time, and so that's going to push up our hourly rate, we could add that in only a couple of lines of code. This is great. But can you spot something about this code that kind of sucks? I'll give you a hint. It's not the incredible sophistication of what I can do here. That's amazing. It's not the use of spreadsheets. Spreadsheets are a great way for us to input data. Is it the output? I guess maybe I could output this to a spreadsheet, but I could do that later, so I guess that doesn't count. It might be something related to correctness, and it might be something that is actually fairly tricky for us to do in pandas and is a fairly tricky thing for us to make sure doesn't accidentally happen when we perform very complex index-aligned operations combined with reduction, specifically things like group by sum in this case. Can you spot what sucks about this code? If you said that reduction operations in pandas, like summing operations or group by sum operations, when dealing with NaN values, will typically assume those NaN values are 0 values. And as a consequence of us taking these simple ideas and building up to more and more and more complex things, we end up building along the lines of what pandas makes easy, which is index alignment. Well, if you combine those two pieces with pandas not warning us when an index alignment results in NaNs, and how easy it is for those NaNs to come into our analysis and then suddenly go missing from the end result or not be visible in the end result, you're absolutely right. Let me show you what I mean. Let's say in this hard-coded data, or may not be hard-coded, maybe another data set, it might be another spreadsheet, it might be a CSV file, whatever the case, somebody wrote apple pies instead of apple pie. Nothing breaks in this code, but the results are completely wrong. They are absolutely wrong. And the reason for that is, if we rewind the analysis that's happening here and remove the group by sum, we'll see, it's going to be a little bit ugly. So here we'll do this on just one of these items. So let's just do this for scenario 1. So we'll just do scenario 1 here. We'll remove the concat, and we'll pull this just here. What you'll see is that when we did the index alignment, and the index alignment, and let's see, why do we have, can I see what we get here? Oh. And we need one more thing here. This should be, yep, that's right. And this should be like that. Oh, no, that's correct, and that's correct. And let's see, what do we have missing here? Oh, we need to pass in the, because these things are named tuples. So these are scenarios. It's a little bit tricky to work with this thing. Okay, so that's that. We'll dump that into that. We'll get this. There we go. What you can see is as a consequence of the index alignment and the index alignment resulting in a NaN, it NaN'd out all these columns. But then as a consequence of the group by with the sum, it added these up, and it basically reflected nothing related to our income or our COGS, and it was just reflecting our staff pay. This is a real problem that has genuinely affected me in my everyday life. I have spreadsheets like this for tracking the P&L of the companies that I run. And if there's a small typo somewhere and an index alignment issue, suddenly you're looking at your P&L forecast for the year and you're completely ignoring state income tax. And everything looks rosy until you realize that you put a space between in and come in state income tax, and then you change that, and then suddenly the analysis looks different, and you could never have noticed it. In fact, it turns out this is quite tricky for us to get pandas to actually warn us of. In general, anytime we are trying to build up very complex and very sophisticated analyses in pandas, and we're using what pandas is good at, which is implicit index alignment, we have to be careful about cases where that index alignment might result in NaNs. And especially cases where there shouldn't be any NaNs. It shouldn't be the case where apple pie doesn't have anything else to match up against when an index aligns. And so what we should be careful of is the D-type that we're using for these index values. For example, when we take a look at these index values that we're setting on this data frame here, one of the things that we might want to do is we might want to make sure that they match up to exactly the index values in the thing that we read from the spreadsheet. So what we'll do is when we read from the spreadsheet, we'll make sure that all of the labels on those rows for the items that we're selling are categorical values. And when we take in some data of another format, for example, this hard-coded data, we'll make sure to convert this index to the exact same categorical values. And so here, if we do that, let's take a look not at the overall analysis, but just at the per unit analysis, just to see if that worked the way we wanted. What we should hopefully see is, that the apple pies flags for us that, you wrote apple pies in one place and apple pie in another place. So this is what it looks like when we did get everything right. This is what it looks like when we got one of these wrong. Well, it turns out that when we use as type with a categorical value, Pandas says, oh, you're asking me what the categorical value for this thing that I've never seen before. Well, it's going to be NaN. So it turns out that we cannot solve this by just making sure everything has joint or has the same categorical D type. That's not a solution for this. You might say, well, a solution for this would be to do that as type with an errors equals raise argument, except as type with errors equals raise is not implemented on the index type. The errors keyword argument only exists on series and data frame as type. So you might say, okay, geez, pandas, what an inconsistent API. I mean, this is what we have to live with, but of course, we can always go and submit pull requests to improve the consistency of the API and the comprehensiveness of it. Well, you might say, well, first do a conversion to a series, and then do an as type, and it'll raise when there's an error when something doesn't match. Except a categorical not lining up when you're doing an as type is not considered an error by Pandas. Pandas just says, well, that's considered missing data. So this solution also doesn't work. When you try to create a categorical index and there's a missing category, this is also not considered an error. In fact, none of these approaches solve what we need to do. What we actually want to do whenever we're reading in some data that's going to be part of some large sophisticated analysis is we need to do some kind of sanity checking on that data. And one of the things that I see almost nobody ever does is, first, we do want these data points to be categorical. So let's make sure that they're categorical, and we'll just choose the simplest way of doing it, the shortest way. But we also, and we of course do not have this errors equals raise, maybe we need to submit a pull request to Pandas to add that flag to the index.as type. I don't know why it's not on index.as type, but it's on everything else.as type. But what we should do is we should put assertions. And those assertions should be assertions of the presence or absence of duplicates on the index, the monotonicity, i.e. the sortedness of the index, and that the index actually contains values and doesn't contain NaNs, because I could have avoided this error, which is a catastrophic error. It will lead to me making terrible decisions as a consequence of one tiny typo. And imagine, as this script becomes more and more complex, it will be very hard for me to get wind of that error unless I know to be looking for it, or unless it's just so egregiously off that I start from scratch in stepping through the analysis. Well, one of the things that I need to do is I need to make sure that I'm putting correct assertions to make sure that I don't have, for example, missing values here, I need to do things like say, if per unit has duplicates, let's do this on the index actually. Let's make sure that there are no duplicates in this thing. Or I think it's here this is the case where we have to do a little dir to remember what all of these things are called. So let's see what that's called there. And we'll turn that off for a second. So that is called has duplicates. Yeah, that's has duplicates, and we're going to also look for is monotonic. So let's see if that gives us what we want. So we'll assert that there's no duplicates. We'll assert that this is monotonically increasing, that's in sorted order, or we can, of course, do a sort on this. We can do a forcible sort on this if we need. And these are things that we should really be doing every time we're constructing one of these, because otherwise, these little NaNs, which will be visible in simple analyses, will actually be very hard to spot the moment you do lots of index alignment and then group by sum, because a group by sum, or even a sum, is going to say, well, a NaN is missing data, so that counts as 0. And it'll be really hard to track down where those are. This is a critical thing because I cannot express to you how catastrophic the error that this caused in my own analysis for my own P&L, for my own company was. It was bad. We were not counting a very significant column. And all I really have to do is just make sure whenever I'm reading some data that I'm really understanding how pandas will work with NaNs, and I'm really checking that that data is correct, up to and including the indexing of that data, up to and including the presence of all these index values. And so it turns out that for how catastrophic this is, pandas makes this a little bit clumsy, but the real answer is not that hard. We just have to make sure that we're making good use of categorical values. We're making sure that everything is lining up because we want things to line up, because we want index alignment to work for us. So it just means, a couple of as-type categories here and there, and just one or two asserts just to make sure that we don't have any latent data issues that are resulting in significant, if not catastrophic, changes. Now, one other thing that you might be aware of is when you do these reduction operations in pandas, there is a skip NA flag. On a column sum, on a series.sum, there is a skip NA flag. It, by default, is set to true, which means that NA value is just considered to be a 0 value. You can, whenever you're doing these sum operations, do a skip NA equals false to really make it clear that if there's a NaN value, you want that to be cascaded through. I actually think that this is not a bad idea, but I can feel just in my gut that I'm not going to be diligent enough to always remember to set skip NA equals false. And if I don't do that in just one small place, then I've lost information about NaNs. Unfortunately, that skip NA flag does not exist on the groupby.sum. Don't ask me why. This is another case where somebody's got to send a pull request to the pandas folks to make the API just a little bit more consistent. And so the other thing is, I not only would have to do a .sum with the skip NA equals false, I'd also have to rewrite all of my group by sums using this formulation, which then adds one more layer of a Python function call into my group by, so that will have some performance impact as well. And so, pandas doesn't make this that easy. I think really the answer is on initial data load, we really should be doing a lot more checking to make sure that everything lines up, because when we do that, everything else becomes easy and we can avoid serious correctness issues that we might have. There's one other thing that some of you I know are thinking, which is don't have NaNs, just drop NaNs. But remember, the NaN value is important information. Do not fill NA, do not drop NA unless you have a affirmative reason to say, for this particular analysis and forever after with this particular piece of data, I do not need to represent the NaNs as what they actually were. I can just represent them as zeros because a fill NA or a drop NA throws away critical information. It throws away critical information that something wasn't present. The moment you start throwing away critical information like that, you're going to find that somewhere down the line you either need to reconstitute it, which ends up being enormously clumsy, or there's just certain things you can no longer do. So if I were to just drop NA in this work, I would have eliminated my ability to later on say, oh, you know what, that shouldn't say that rib sandwich, that unspecified branded rib sandwich is not sold during certain periods of time, and that's why it has P&L of 0. It's not the case that we're selling it at cost or something else. And that's a very meaningful part of my analysis, to know that there's a difference between selling something but making $0 on it and not selling something at all. So the answer is not and will never be just drop NA or fill NA. The answer is be much more careful about how you deal with these NAs and know the consequences of what happens when you do these reduction operations.